And welcome back, students. Let's jump into our next lesson on throwing exceptions and methods. We're going to this time talk about exceptions to the catch or declare rule. And so getting started, so obviously we've talked about the catch or declare rule in previous lessons. Obviously you might have heard the phrase, with every rule there is an exception to it. So this is that rule that has the exception. As we've already noted, in most quote-unquote ordinary cases, an exception pretty much either must be caught in a catch block or declared within a throws clause. This is because the catch or declare rule, but as I already alluded to, there are exceptions to the rule. Right. There are some classes whose exceptions you do not need to account for in this way, though you can catch them in a catch block if you want to. These are typically exceptions that would result from errors of some sort. And they usually indicate that your code should be fixed, but not necessarily that you need to add a catch block. They're often thrown by methods in standard library classes, but it would be legal to throw one of these exceptions in the code you write. Now, therefore, exceptions that are descendants of the class runtime exception do not need to be accounted for in a catch block or a throws clause. Another category of classes called error classes behave like exception classes in that they can be thrown and caught in a catch block. However, you're not required to account for error objects in a catch or throws clause, so you don't have to worry about these. Now, the situation is kind of diagrammed as a class hierarchy on the next slide. You'll notice that all the classes shown in blue follow the catch or declare rule, which says that if their objects are thrown, then they must either be caught in the catch block or declared within the throws clause. All the classes shown in yellow are exempt from that catch or declare rule. So here's our hierarchy, and in here you have all the sense of the class throwable can be thrown and caught in a catch block. Right? And it either will be there's an exception or an error. Right? Now these are checked exceptions, means they're subject to the catch or declare rule, and errors, all of which do not need to be accounted for in a catch block or a throws clause. All right, the exception either then breaks off into a runtime exception or exceptions that have to be caught within a catch block or declared in a throws clause. Runtime exception says exceptions that do not need to be accounted for in a catch block or throws clause. So let's take a look in just a moment and examine what happens if an exception is never caught. So if every method up to and including the main method simply includes a throws clause for a particular class of exceptions, then it may turn out that an exception of the class is thrown but never caught. In such cases, when an exception is thrown but never caught, then for the kinds of programs we've seen so far, the program ends with an error message giving the name of the exception class. Now, in programming 3, actually, we will discuss programming with windowing interfaces known as GUI programs. We actually deal a little bit with swing and stuff like that. And in those GUI programs, if an exception is thrown but never caught, nothing really happens. Instead, your code just does not somehow account for the thrown exception, and the user may be left in an unexplained situation. They're just like, what's going on? All right, program might like lock up, for example, and they're just kind of left there because it's not like with the terminal. When we're working with the console line, we can easily generate an output. Can't do that as well on a GUI interface. Now, in a well-written program, every exception that is thrown should eventually be caught by a catch block in some method. All right, really quickly, let's talk about checked and unchecked exceptions. Now, exception classes that follow the catch or declare rule are often known as checked exceptions because you have to check to see if it's going to throw an exception. Exceptions that are exempt from that rule are often called unchecked exceptions. You do not need to worry too much about which exemptions you do and do not need to declare in a throws clause. So if you're a little confused at this point, don't really have to worry about too much, because if you fail to account for some exception that Java requires you to account for, the compiler is going to tell you about it. And then you either need to catch it or declare it in the throws clause. Now, exceptions that are subject to the catch or declare rule are called unchecked exceptions, because the compiler checks to see if they are accounted for with a catch block or a throws clause. Now, the classes throwable, exception, and all descendants of the class exception are therefore checked exceptions. Exceptions that are not subject to the catch or declare rule, as you recall, are unchecked exceptions. So all other exemptions are unchecked exceptions. Now, the class error and all its descendant classes are called error classes and not subject to the catch or declare rule. Now, although they're technically not exceptions, you can safely consider these error classes to be considered unchecked exemptions because ultimately the program's not checking to see whether or not they're accounted for. And strictly speaking, if you look at the class throwable, it's neither an exception nor is it an error class, but it is seldom used and can be treated as a checked exemption if it is used. So if you have to throw something, even though when you throw something, it's technically not an error class or it's not an exemption, the throwable objects, when you write throws, how the program's treating it is that it is a checked exemption. All right, and one last thing to talk about for today, which is the throws clause in derived classes. So whenever you override a method definition in a derived class, it should have the same exemption classes listed in its throws clause that it would have in its base class, or should have a throws clause whose exemptions are a subset in the base class throws clause. So put it in another way, when you override a method definition, you cannot add any exemptions to the throws clause, but you can delete some exemptions if you want. You can also replace an exemption class by any descendant exemption class. Now, obviously, if you think about this, kind of makes sense because an object of the derived class might be used anyplace an object of the base class is used. So an overridden method must fit into any code written for an object of the base class. All right, think back to our employee objects where we had employee and salaried employee. The salaried employee object is a derived class of our employee object, and so therefore when we make that salaried employee object, we're going to expect that it can function in pretty much like a lot of the same methods that are existing within the base class because it's just a derived class. So you got to make sure that those throwable clauses still work. All right, and that's going to wrap it up for today, folks. So we will see you next time.